So today's lesson is going to be based on rational exponents. So the first question is, what is a rational exponent? So a rational exponent is an exponent that is a fraction, right? So to start off this lesson, we're going to take a look at this square root symbol. So what exactly does the square root symbol mean? And if I took an example of the square root of 4, so this is an example, what we actually mean is what number multiplied by itself equals 4. So in this case, the answer to the square root of 4 is 2. Now, another way that we can actually write this is using a rational exponent, where this square root symbol actually means to the exponent of 1/2. So that's another way to write it. Now, another way using the full notation with the root symbol is to write the denominator beside the root symbol. So since this denominator is 2, this is where we would actually write the 2 beside the root symbol. Now, it's only significant when we start having roots with different denominators. Up until now, we've only had to deal with square roots, so that is why we normally don't put in the 2 there, because it is so commonly used. So if we actually take a look at this next example, so 16 to the exponent of 1/2, I can write it in 2 different ways. So 16 to the exponent 1/2, we can use the root symbol without the exponent because this is commonly used, or if we're going to use the root symbol and show what the denominator is, then I would have the root 2 and the 16 underneath. All right? Now, this root symbol comes into play when I'm dealing with different denominators. So, for example, how would we represent 8 to the exponent of 1/3 using this root symbol? So since the denominator is 3, then I would use root and 3 in the corner and then the 8 underneath. Now, the next question is, what happens when I start having numbers other than 1 in the numerator? So at this point, for this question here, the 1 would be written underneath. So I can do the same thing with respect to 8 to the exponent 2/3. Now, the best way to actually write it is I'm going to do the 3rd root of 8, and then whatever that answer is, I'm going to square it. All right? So the reason we want to put the squared on the outside is because it actually makes our calculations a lot easier. So what number multiplied by itself 3 times equals 8? So that's what all of this in the bracket actually means. So if we think about it, 2 times 2 times 2, that's the number that gets multiplied 3 times to give me 8. So inside this bracket is actually 2, so then I have 2 squared, and then 2 squared is equal to 4. So that's what we can do with respect to rational exponents, is I can use the root to reduce the value, and then with the numerator is actually our regular exponent hanging out on the outside of the bracket. So if we now take a look at some examples, and we're just going to put this all together using the root symbols, and then we're going to calculate it without having to use a calculator. So if you want to try some of these questions on your own, you can pause the video and then start it back up to see if you're on the right track. All right, so to continue along, we're going to take a look at 100 to the exponent 1/2. So what this means is I actually have 100 to the root 2, and then that is technically to the exponent 1. So what number multiplied by itself twice equals 100? That is 10 to the exponent 1. So my final answer is 10. So then if I take a look at the next question, so I have the 5th root of 32, and then all to the exponent 1. And so what number multiplied by itself 5 times gives me 32? So that works out to be 2 to the exponent 1, so that's equal to 2. So now if we start implementing or using exponents that have a number other than 1 in the numerator, so if we take a look at 16 to the exponent of 3/4, we have the 4th root of 16 all cubed. So then if I'm solving this, I end up with a number multiplied by itself 4 times to give me 16. That works out to be 2. And that answer is cubed. 2 times 2 times 2 then works out to be 8. And then example D, if we have 36 to the exponent of 3/2, so that means we have the 2nd root of 36 all cubed. So then we end up with a number, or the square root of 36, which works out to be 6, and then 6 cubed works out to be 216. All right, so the next example, we want to be a little bit careful. So if you notice, it is the negative 64 to the exponent of 2/3. So what you have to keep in mind is this negative is actually outside of the brackets. So when I do this, then that means I'm going to have the negative out in front, and then I'm going to take the 3rd root of 64, and then I'm going to square that 3rd root. So what I end up with is negative 4 squared, which then leaves me with negative 16. So hopefully, so far so good. The next thing that we're dealing with is negative exponents. So anytime we're dealing with negative exponents, just like we talked about yesterday, what we're going to do is I actually have 16 as a fraction over 1. So to take care of the negative first, I'm going to flip that fraction, which is now 1 over 16, all to the exponent of 1/2. All right, so then what we can do is I can apply this 1/2, or this square root, to both pieces. So I end up with the 2nd root of 1 over the 2nd root of 16. Now, because the numerator is 1, I don't actually need to worry about applying that exponent, so I end up with the square root of 1 is 1, and then this, or the 2nd root of 16 is 4. All right, so now if we deal with our last example, and this example is a negative exponent and it has a number other than 1 on the numerator, we're going to apply sort of everything that we've done so far, and in this case, the first thing I'm going to do is get rid of that negative exponent. So I'm going to flip my fraction, so I end up with 27 over 64 to the exponent of 2/3. And then I'm going to apply my roots and my squared. So in this case, I have the 3rd root of 27, and all of that is squared. All right, so I can apply it to the top, and then I can apply it to the bottom. So it would be the 3rd root of 64, and then that entire piece is also squared. So we're using some of the exponent laws that we talked about yesterday. So then the 3rd root of 27 works out to be 3, so I have 3 squared, and the 3rd root of 64 is 4 squared, so then my final answer here works out to be 9 over 16. So hopefully this lesson made some sense, and tomorrow in class we're going to take a look at some of the homework and work through some questions in groups.